Hello students. Welcome back to Dishapu online classes. So as you all know, in the previous video we were solving the problems based on arithmetic progression, right? In this video also let us continue with a few more problems, right? So in this chapter you will get more number of problems. Okay, so let us see the next one. Sum of first P, Q and R terms of an arithmetic progression are A, B and C. Right? So here what we are given? We are given sum of first P terms of an AP is equal to A. Sum of first Q terms of an AP is equal to B. And sum of first R terms of an AP is equal to C. Respectively. This is the given thing. So what we have to do here, we have to prove that A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q is equal to 0. Right? So this is the thing that we want to prove here in this question. Right? So let us solve this. Solution. First, let us write the given thing. What is given? Given. See, we are given sum of first P terms of an AP. Right? Sum of first P terms in the sense it is given by SP. Right? What is the formula for sum of n terms? N by 2. That is, in the place of n we have P into 2. See here. Sum of first P terms of an AP is given as small a. Right? So what we will do here is we will consider, let capital A be the first term, and D be the common difference. D be the common difference of an AP. Right? So why am I considering capital A as the first term here? Because we are given sum of first P terms is small a. Right? So in order, that is to avoid the confusion, I am taking capital A as the first term. So now let us write the given. What is given for us? Sum of first P terms is equal to P by 2 into capital A. I am taking capital A as the first term plus n minus 1 into D. In place of n we have P into D is equal to, this is given as A. Right? So now what I will do is, I will transfer these two terms to the RHS and I will write. What do we get? 2A plus P minus 1 into D is equal to, this goes to the numerator, 2A divided by P. Let us consider this as equation 1. Right? So I hope you understood this. Next. We are also given sum of first Q terms of an AP. What is the value? It is equal to B. Sum of first Q terms is given by SQ is equal to, in place of n we have Q, that is Q by 2 into we have considered capital A as the first term plus Q minus 1 into D. This is given as B. Right? So now I will transfer these two terms to the RHS. What I will get? 2A plus Q minus 1 into D is equal to 2B divided by Q. Let us consider this as second equation. Right? And what is the last thing given? Sum of first R terms. It is equal to what? C. So this will be R by 2. 2A plus R minus 1 into D. This is given as C. Right? So this will be what? 2A plus R minus 1 into D is equal to 2C divided by R. Let us take this as equation 3. So I hope you understood till here. I have written just the given terms. So now what I have to do? I have to prove this condition, right? So how will I prove this condition? See here, using equation 1, 2 and 3, we are going to prove this. So how do we prove? What I will do here is, I will subtract the first and second equation and I will get some term. I will subtract the second and third equation and I will get some term. Right? So when I obtain two terms by solving this, again I will use those terms and I will prove this. Right? So let us see how do we prove this. See, what I will do here is, I will subtract equation number 2 from equation number 1. Right? That is nothing but equation 1 minus equation 2. What is equation number 1? We will subtract LHS to LHS and RHS to RHS, right? So what is equation number 1? 2a plus p minus 1 into d, right? What is the LHS of equation number 2? Minus 2a plus q minus 1 into d. This is equal to, what is RHS? 2a by p minus 2b by q. Right? This is the RHS of second one. Now, 2a plus p minus 1 into d, open the bracket, minus into plus is minus, you will get 2 into a here, minus into plus is minus of q minus 1 into d is equal to c. Here I will get p into q as LCM. Here I will be remained with q. Here I will be wanting p. Right? So you will get what? 2aq minus 2bp. Right? So I hope you understood that. Now, plus 2a minus 2a get cancelled here. So what you are remained with? P minus 1 into d, right, minus of q minus 1 into d is equal to, 2 is common in both the terms, so take it outside. So I will get aq minus bp divided by pq. So this is what I get, right? So let us continue with this. So see here what I will get. See, in these two terms d is common. So take it outside and write. What I will get? P minus 1 as it is. So see here. Minus into plus is minus q. Minus into minus is plus 1 into d is equal to 2 into aq minus bp divided by pq, right? Plus 1 minus 1 will be cancelled here. So you are remained with what? P minus q into d is equal to 2 into aq minus bp divided by pq, right? So what I will do here is, I will keep d to the LHS and I will transfer this term to the RHS. So this will come to the denominator. So what you will get here? 2 into aq minus bp divided by pq into p minus q. Right? So let us consider this as equation number 4. So what we have done? We have taken 1 minus 2 and we have obtained d is equal to this term. Let us consider this as equation number 4. Right? So now what I will do is, I will subtract equation number 2 and 3 and I will see what I will get. Right? So see. So what we will get next? Subtract equation number 3 from equation number 2. To equation 3 from 2 in the sense 2 minus 3. So we will see what we will get. We get, so what is equation number 2? 2a plus q minus 1 into d minus of, what is equation number 3? 2a plus r minus 1 into d is equal to, what is RHS? 2b by q minus 2c divided by r. Right? So now the same thing goes on here, right? How did we solve there? The same we have to solve here. So 2a plus q minus 1 into d, minus into plus is minus 2a, minus into plus is minus r minus 1 into d is equal to, see, we have got q into r as LCM here, right? We will get r q into r as LCM. So here we want r, here we will be wanting q. So you will get 2br minus 2cq, right? Plus 2a minus 2a get cancelled. So in these two terms d is common. So take it outside, what you will get? Q minus 1, minus into plus is minus, 1 into r is r, minus into minus is plus, 1 into 1 is 1 into d is equal to, 2 is common in both the terms. So it will be br minus cq divided by q into r. Minus 1 plus 1 we cancelled here. So you are remained with q minus r into d is equal to 2 into br minus cq by qr. So now what I will do, I will transfer q minus r to the RHS. So what I will get, d is equal to 2 into br minus cq divided by qr into q minus r. Let us take this as equation number 5. Right? So now as you can observe in equation number 4 and 5, the LHS is same. Right? What is the LHS term? LHS term is the common difference for the given AP. Right? So D, the value of D for both the equations will be same. So if the LHS of both the equations are same, then RHS of both the equations will also be same. Right? LHS of 4 and 5 is same. So RHS of 4 and 5 will also be same. So what I will do here, I will equate equation number 4 and 5. So let us do that. Now equating equation 4 and equation 5. What do I get? What is equation number 4? 2 into AQ minus BP divided by PQ into P minus Q is equal to, what is equation number 5? 2 into BR minus CQ. 2 into BR minus CQ whole divided by QR into Q minus R. QR into Q minus R. Right? So now here 2 get cancelled, because if I transfer this to the RHS, it will come to the denominator. Now if I transfer this Q to the RHS, it will go to the numerator. So Q get cancelled here. Right? So what I will be remained with? See what I will be remained with here? AQ minus BP divided by P into P minus Q is equal to BR minus CQ divided by R into Q minus R. Right? So the next thing what I will do is, I will cross multiply the terms. Right? I will transfer this to LHS and I will transfer this to RHS. Let us see what we will get. R into AQ minus BP into Q minus R, that is C. I am multiplying R into Q minus R to this. So I can write like this also, R into AQ minus BP into Q minus R. It is product, right? So equal to, I am transferring this to RHS. So it will be P into BR minus CQ into P minus Q. Right? Now what I will do, I will multiply the term outside the bracket to the terms inside the bracket. So what I will get, R into AQ, right, minus R into BP, right, into Q minus R is equal to, again I will multiply P inside the bracket. So P into BR minus P into CQ into P minus Q. Right? So this is the simplification that we have done now, equating 4 and 5. But what do I want to prove? I want to prove A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q is equal to 0. I have to prove that term. Right? I hope you have written the question. C in that. So how to prove that? So what I will do here is, I will divide the terms of LHS and RHS by P into Q into R. What I will do? I will dividing by P into Q into R on both the sides of this equation. Right? So what do I get when I divide that? See here. RAQ minus RBP into Q minus R, right? Divided by, what am I dividing with? I am dividing with PQR is equal to PBR minus PCQ into P minus Q. What am I dividing with? I am dividing with the PQR. Right? So next. So I hope you are writing the solution. Now, so see, in the numerator I have product of two terms. In the denominator I have one term, right? That is PQR. This is whole one term, and here we have product of two terms. So assume that if I have A by B, A into B by 2, can I write it as A by 2 into B? Both are nothing to the same, right? So in the same way, what I will do for that is, let us take this as A and B, that is A into B by 2. So what I will do, I will go for A by 2 into B, right? So what I will get, RAQ minus RBP divided by PQR into, I have Q minus R, right, is equal to, the same thing I will do for RHS term also, that is PBR minus PCQ divided by PQR into P minus Q, right? So next. Now, see, if I have A minus B by 2, right? Just assume that I have A minus B by 2. How can I write A minus B by 2 as, I can write it as A by 2 minus B by 2. I can split the term. Why? Because denominator is same for both, right? So here LCM will be 2 again. It will be 2 ones, it will be 2 ones. So you will get A minus B in the numerator. So A minus B by 2 can be written as A by 2 minus B by 2. Am I right? So see here, A minus B by 2. So I can write it in the form of A by 2 minus B by 2. Right? So let us write it that way. See, RAQ divided by PQR, right, minus RBP divided by PQR, right, into what, Q minus R is equal to Again the same thing I can do here, a minus b by 2. So it can be written as a by 2 minus b by 2. Right? Into what? P minus Q. So I hope you understood how did I write this. Now QR cancels. PR get cancelled. Right? So here PR get cancelled, and here PQ get cancelled. So what am I remained with? I will be remained with, see here, in the numerator I have A, in the denominator I have B, minus in the numerator I have B, in the denominator I have Q, into Q minus R is equal to, here I will be remained with B by Q, here I will be remained with C by R, into what? P minus Q. Right? So I hope you understood till here. Next, see, now what I will do, I will multiply each term of this bracket to this bracket, right? So what I will get, a by p into q minus r, minus into plus is minus, b by q into q minus r, right, is equal to, again I will do the same thing. So I will get b by q into p minus q, minus c by r into p minus q, right? So continuing this, I will transfer the terms of RHS to the LHS, and I will see what I will get here. A by p into q minus r, minus b by q into q minus r, right? Or else do one thing. Here also we have b by q, here also we have b by q. Let us take these two terms one side and let us transfer this to the LHS. So what I will get? Plus c by r into p minus q is equal to, right? See here, when I take this to the RHS, this is as it is. When I take this, I will get it as plus b by q into q minus r. Right? I can also write like this now. See, I will write LHS as it is. That is a by p into q minus r plus c by r into p minus q is equal to, see here, in these two terms b by q is common, so take it outside. B by q into what I will get in the bracket, p minus q as it is. Here see, plus into plus is plus, so plus q, plus into minus is minus, so minus r, so plus q minus q get cancelled, right? A by p into q minus r plus c by r into p minus q is equal to b by q into p minus r. So this is the thing we have got. But see in the proof, you just see the question, what we have to prove, a by p into q minus r plus b by q into r minus p, right, plus c by r into p minus q. So already we have two terms. One required term is what, b by q into r minus p, but here in the LHS what do we have? We have b by q into p minus r, right? So in order to make it r minus p, see, 1 is the coefficient here, so if I take minus 1 outside, will I get r minus p here, right? So let's see how will I write that. A by p into q minus r plus c by r into p minus q is equal to, I am taking minus outside, I will get b by q into r minus p. Minus into plus is minus, 1 into r is r again. Minus into minus is plus, 1 into p is p again. Again if you multiply minus 1 inside the bracket, you will get p minus r. Right? So let us transfer this to the LHS. So what I will get? A by p into q minus r plus b by q into r minus p plus c by r into p minus q is equal to 0. Right? So I hope you understood this. Right? So this is the proof that we wanted. So I hope you understood how to solve, right? Therefore, hence we have proved the given. Right? So I hope you understood how to solve this. Right? So let us now move on to the next question. Right. So the next one. If the sum of n terms of an AP is 3n square plus 5n, right? So what are we given? We are given with the sum of n terms of an AP, right? So sum of n terms of an AP is given by Sn. So it is given as what? 3n square plus 5n, right? And its mth term is 164. Right? What are we given? We are also given the mth term of the arithmetic progression. Mth term in the sense what? We write it as am. Right? So this is equal to, what is the nth term formula? A plus n minus 1 into d. Here in place of n we have m. So a plus m minus 1 into d. This is given as 164. Right? So let us take this as 1. Now, find the value of m. What we have to find out? We have to find out this value of m. So in order to find the value of m, using the nth term formula, we should know the first term of the arithmetic progression as well as the common difference of the arithmetic progression and mth term. Right? We should know the value of this, we should know the value of A, we should know the value of D. So when we know the three things, we can easily find out the value of m. So I already know the value of am. What is that? 164. Right? So now what I have to do? I have to find out the value of A and D. That is first term as well as the common difference. So let us use this equation, that is given sum, and calculate the first term as well as the common difference. Right? So previously you have solved a problem where you were given what? Sum of n terms, and you were asked to find out the common difference there. So how did you find out? Right? So see here, let Sn is equal to, Sn is nothing but what? Sum of n terms, that is a1 plus a2 plus a3 plus so on plus an. Right? So this is equal to what? That is given as 3n square plus 5n. Right? So now, when I take n is equal to 1, I will get s1. You already have solved this kind of a problem. The only difference is, there we were asked to find out the common difference, we here are asked to find out the value of m. Right? So in order to find the value of m, we need the common difference. So we already know how to calculate the common difference. S1 is nothing but what? Sum of the first term. So this is a1 equal to, put n is equal to 1 there. 3 into 1 square plus 5 into 1 is equal to, 1 square is 1, 3 into 1 is 3. 5 into 1 is 5. 3 plus 5 is 8. Right? Next, take n is equal to 2. What do you get? S2 is equal to, S2 is nothing but sum of first two terms is equal to, put 2 in the n, 3 into 2 square plus 5 into 2, right? We know the value of a1. What is that? 8. Substitute. What I will get? 8 plus a2 is equal to, 2 square is 4, 4 3 is 12, 5 plus 5 into 2 is 10, right? So 12 plus 10 is what? It is equal to 22. Am I right? So I need the value of a2. So 22 minus 8. So a2 will be 14. So this is the value of a2 and this is the value of a1. Right? So I have got the first term of the arithmetic progression. Now I need common difference. How will you find out the common difference? Common difference d is equal to a2 minus a1. Right? What is the value of a2? 14. What is the value of a1? 8. So therefore d is equal to 6. Now see here. I know the value of first term a, that is equal to 8. I know the value of common difference, that is equal to 6. I know the value of am, that is equal to 164. So now can I calculate the value of m here? Right? So let us substitute the values in 1 and let us solve this. Right? So now equation number 1 implies, see here, a, what is the value of a first term? 8 plus, we have to find out the value of m. What is the value of d that I have got? Into 6 is equal to, I have 164. Correct? So this implies 8 plus into plus is plus into plus is plus. So 6m. Plus into minus is minus into plus is minus. 1 into 6 is 6 is equal to 164. Right? So what do I get now? 8 minus 6 is 2. So I will get here 6m plus 2 is equal to 164. Right? 6m is equal to 164 minus 2 because I need the value of m. So I will keep it to LHS and I will transfer all the terms to RHS. So 6m is equal to, it becomes 162. So m is equal to 162 by 6. So 6 ones are 6 twos is 12. Here 4 carried, so remaining is 4, so 6 sevens is 42. So the value of m is 27. Right? So I hope you understood what we have done. We have first written the given, right? And we have used this and we have solved for first term as well as common difference, and we have substituted in this and I have got the value of m. So this is how you solve this problem. Right? So I hope you understood this. Right? Let us move on to the next one. Right, the next questions. A man starts repaying a loan as first installment of rupees 100. Right? If he increases the installment by rupees 5 every month. So what is given here? The first installment of a loan he will pay rupees 100. That this is the first term now. Right? If he increases the installment by rupees 5 every month. So every month when he will be paying the installment, he is increasing the amount by rupees 5. Right? That is first installment he is paying 100 rupees. Next month he will pay 105 rupees. Next he will pay 110 rupees. Next he will pay 120 rupees. Right? So the difference is common. So this is the common difference given. What we have to do? What amount he will pay in the 30th installment. So what we have to find out here is when he will pay the 30th installment of his loan, what amount he will pay. Right? So what do you mean by this? You have to calculate the 30th term of the arithmetic progression. This becomes an arithmetic progression. First installment 100, next installment 105, 110, 120, 115, 120, so on. So the difference is common. So this becomes arithmetic progression. So you have to find out the 30th term. So use the nth term formula. An is equal to a plus n minus 1 into d. The value of a is 100, the value of d is 5, and the value of n is equal to 30. So find out the a 30th term. This is for your home assignment. Right? So let us solve the next question. So what is that? The difference between any two consecutive interior angles of a polygon. The difference between any two consecutive interior angles of a polygon. Here we are given polygon. What do you mean by a polygon? Any closed figure. Right? For example, take triangle. Take any four-sided figure, quadrilateral, right? Pentagon, hexagon, it goes on like that, right? So see here, what is given? The difference between any two consecutive interior angles of a polygon. Consecutive interior angles in the sense, see, these two are consecutive, these two are consecutive, these two are consecutive. One after the other, right? That is, these two are consecutive angles, these two are consecutive angles, these two are consecutive, these two are consecutive, and these two are consecutive. The difference between any two consecutive angles must be what? It must be 5 degrees. That is, the difference between this angle and this angle must be 5 degrees. Right? So this is given. If the smallest angle is 120 degree, what is the smallest angle of the polygon? It is 120 degree, right? So what we have to find out? Find the number of sides of the polygon. What we have to do? We have to find out the number of sides. How many number of sides are there for a polygon? If its smallest angle is 120 degree and the difference between two consecutive angles is 5 degrees. So let us see. See, observe here, how many sides are there? There are 3 sides. Here we have 4 sides. Here we have 5 sides. Here we have 6 sides. We have 3 sides as well as 3 angles. We have 4 sides as well as 4 angles. We have 5 sides as well as 5 angles. We have 6 sides as well as 6 angles. Right? So observe here, how many sides you will be having for a polygon, those many angles will be there for a polygon. That is, total number of sides of a polygon will be equal to total number of angles. Am I right? How many sides will be there for a polygon, those many angles will be there for a polygon. Right? So number of sides of a polygon is equal to number of angles of a polygon. So if I find how many angles are there for the given polygon, that will be equal to number of sides. Right? So see here, we are not particularly given how many sides are there for a polygon. So what will we do here is, see, we are not given how many sides are there. So what I will do, let me consider hexagon. Right? The smallest angle of the polygon is given 120 degrees. And the difference between the consecutive angles is 5. So this will be 125 degrees. No sir, I can consider 115 also, because 120 minus 115 is again 5. But you cannot consider 115. Why? Because the smallest angle itself is 120. If you take 115 as the next angle, then you are going against the given term, right? So your next term will be 125. This is smallest angle 120, this is 125, this will be 130, this will be 135, this is 140, 145, it goes so on. Why? Because we don't know how many number of sides are there. If we would have known the number of sides, then we would have written how many angles are there. So there are n number of angles, right? So see here, The difference is common, that is we will get 5 when we subtract those two terms. So will this become an arithmetic progression? Obviously this will become an arithmetic progression. So see here, what is the arithmetic progression? Solution. Let the APB, what is that? 120 degrees, 125 degrees, 130 degrees, so on. Right? So this will be your AP. Right? Now, here the first term, that is A is equal to 120 degrees, and the common difference D is 125 minus 120, that is given already, that is 5 degrees. Right? So now what I have to find? I have to find the number of sides of the polygon. Just now I have told you that the number of sides of a polygon is equal to number of angles. Right? So if I find how many angles are there for a polygon, those many sides will be there for a polygon. So let us concentrate on finding the number of angles. Right? So see here, what I have written? I have written angles here. So these are what? These are all terms of the arithmetic progression. Right? So if I want to find out the number of angles, that means what? I have to find out how many terms are there in this arithmetic progression. If I find out the number of terms in the arithmetic progression, that will be equal to number of sides. Am I right? So number of terms in the sense what? It is the value of n I have to calculate. So let us take nth term an is equal to a plus n minus 1 into d. You know the value of a, you know the value of d. You have to calculate the value of n. So in order to calculate the value of n, you need the nth term. Do you have the nth term there? You don't have. Why? Because you don't know the end point there. Am I right? You don't know what is the end angle for this given AP. So there is no nth term you have. So you cannot use this formula to calculate the value of n. Why? Because you don't know the value of an. So how to calculate this? See here. See, we know that sum of all angles of a polygon, sum of all angles of a polygon is equal to n minus 2 into 180 degrees. All interior angles of a polygon or all angles of a polygon is equal to what? N minus 2 into 180 degrees. This thing you have studied in your 8th standard. What you have studied? Sum of angles of all the angles of a polygon is given by n minus 2 into 180 degrees, where n represents what? Number of sides of a polygon. Am I right? So take n is equal to 3, that is a triangle. 3 minus 2 is 1, 1 into 180 degrees is 180 degrees. So sum of all angles of a triangle is 180 degrees. Take n is equal to 4, any quadrilateral. 4 minus 2 is 2, 2 into 180 is 360 degree. So sum of all angles of a quadrilateral is 360 degrees. Right? So this is the relation between what? Number of sides and angles of a polygon. This you have studied in 8th standard. Now, sum of all angles of a polygon. What do you mean by that? You don't know how many angles are there, right? You have to find out the value of n. So the formula of sum is given by what? Sn. Why? Because all the angles are forming the arithmetic progression. So when you add all the angles, you are getting this. Am I right? So all the angles are in the form of an AP. So here I can use Sn formula. What is the Sn formula? N by 2. 2a plus n minus 1 into d is equal to, this is equal to what? N minus 2 into 180 degrees. Right? So this is how you get. Now, you have to find out the value of n, so keep it as it is. You know the value of a. What is it? 120 degrees. Plus, you have to find out the value of n. You know the value of d, that is 5 degrees, is equal to n minus 2 into 180 degrees. right? So now take this n into 2 into 120 becomes, it is 240 degrees, right? 240 plus into plus is plus into plus is plus, that is 5n, plus into minus is minus, minus into plus is minus, 1 into 5 is 5, is equal to n minus 2 into 180 degrees, right? Now what I will do here is, see, there is 2 in the denominator, I will transfer this to that side, so it becomes 180 into 2, so what will this be? This will be 360, right? So now n into 240 minus 5 is 235 plus 5n, right, is equal to 360 into n is 360n minus 360 2 is 720, right? So what I have done here, I have taken the relation between what, sum of all the angles to the number of sides of a polygon. Sum of all angles is given by this formula and I have simplified this here, right? Right. So the next, see here, I will multiply this term to the terms of the bracket. So what I will get, 235n plus 5 into n square is equal to 360n minus 720, right? I will transfer these two terms to the LHS. What I will get, 5n square plus 235n as it is, this will become minus 360n and this will become plus 720, right? So 5n square, now signs are different, subtract and put the greater number sign. Greater number sign is minus. When you subtract these two, you will get 125n plus 720. So this is equal to 0. Plus 720 is equal to 0. Right? So now 5 is common in these three terms. Right? Because this number is ending with 5, this is ending with 0. So these are multiples of 5. So 5 is common, take it outside. N square minus 25n plus 144. You will get this one. N square into 5 is 5n square, 25 5 is 125, 144 into 5 is 720. Right? So next. See, this goes to denominator here, so 0 by 5 is again 0. So you are remained with what? N square minus 25n plus 144 is equal to 0. Right? This is a quadratic equation. Right? So we will split the middle term and we will find out the value of n. So what is that? 144 n square. So I will take 16n and 9n. 16 9 is 144, n into n is n square. Minus minus. Signs are same, add and put the same sign. 16 plus 9 is 25, sign will be minus. Right? So in what way I will split this? N square minus 16n minus 9n plus 144 is equal to 0. Right? So the next. Next what I will get? N is common between these two terms. So n into n minus 16. N minus 16 you will write as it is here. Here you will get minus 9 is equal to 0. So this will be n minus 16. N minus 9 is equal to 0. So when you equate these two terms equal to 0 at a time, you will get what? One is n equal to 16 or n is equal to 9. Right? So here you have got two values of n, but only n is equal to 9 is correct, but n is equal to 16 is not. Why n is equal to 16 is not correct? Let us see here. Why is it not correct? See here, I will consider a polygon. Right? Now, You all know that the angle for a straight line is 180 degrees. Am I right? So see here, when I draw this polygon, see, I will take a straight line here. So this is of 180 degrees, just assume that, right? Now, if the angle is more than 180 degree, assume that the angle is more than 180 degree. So how will this line go? This will slightly take a turn here, right? It is more than 180. When you take like this, it becomes less than 180, right? So here what we are doing, we are taking an angle more than 180, so the line goes in this way. So now you tell me, is it possible for us to form a closed figure when the angle is more than 180 degrees? See, it is clearly not possible. To form a polygon, the angles must be less than 180 degrees. See here. It is less than 180 degree. It is less than 180 degrees. If I take this as greater than 180, then it will take a turn like this. So it is not possible for us to form a closed figure when any one angle of the polygon is greater than 180 degree. It does not form a polygon actually. Am I right? So let us see why n is equal to 16 is not possible. See here, what we have found? We have found the number of terms in the arithmetic progression. Am I right? So if there are 9 number of terms, let us assume, right? So we will take number of terms as 9, right? So what we know the formula for an. An is a plus n minus 1 into d. So if n is equal to 9, a9 is equal to, the first term is 120 degrees plus n value is 9 minus 1 into the common difference is 5 degrees. So a9 is equal to 120 degrees plus, so 9 minus 1 is 8, 8 5 is 40. So this is 160 degrees, right? So what is the ninth term of the arithmetic progression? It is 160 degrees. Is it less than 180? Yes, it is less than 180. So how many terms are there in arithmetic progression? 9 number of terms are there, and all the angles are what? They are less than 180 degree. So it is possible for me to form a closed figure, that is a 9-sided figure. Am I right? So in the same way we will take if n is equal to 16. If n is equal to 16, see what happens. It will be a16, a value is 120 degrees plus 16 minus 1 into 5 degrees. So what you will get, 120 degrees plus 16 minus 1 is 15, 15 5 is 75 degrees is equal to 195 degrees. What is the 16th angle? That is 195 degrees. Is it less than 180? It is not less than 180 degrees. If the angle is more than 180 degrees, then you cannot form a closed figure. You cannot form a polygon there. Right? So that is why n is equal to 16 is not possible. N is equal to 9 is possible. Why? Because the angle here is less than 180 degrees. So what will be your answer? See, this is not possible. This is not possible. Why is it not possible? Because if n is equal to 16, your angle is greater than 180 degrees. This is not at all possible. So the number of terms of the number of sides of the given polygon are what? Equal to 9. So this is possible, right? So what will be your answer? What will be your answer? Therefore, n is equal to 9. The required number the required number of the sides of the polygon are what? 9. This is your answer, right? So I hope you understood why n is equal to 16 is not possible, right? So here the problems based on arithmetic progression are over. Next what we will do, we will learn a bit about arithmetic